Students, this is the last part of this chapter, energy stored in a capacitor. Let me discuss you how the energy is being stored in a capacitor. Already I have defined what a capacitor is. Capacitor is a device that can store charges, or we can say it can store electrical energy. How? When the capacitor is charged, see, suppose you have an uncharged capacitor, means these two plates, they do not have any kind of charge. You have to charge it, means you have to charge one plate positively by an amount of plus Q. So that you can only do by connecting it to a battery or through some external sources. Or we can otherwise say, you take one electron from this plate and place it here. So this plate will be deficit by an amount of one electron, so it gets a positively charged. The equal amount of negatively charged is here. So try to understand it. This cannot be done like that. So because of that reason, a battery is connected across the plate of the capacitor. So what is happening? From the negative plate of the battery, one electron is coming and it is charging the plate of this capacitor. Because of the process of induction, this plate gets positively charged and the equivalent amount of negatively charged is it is sent to the positive terminal of the battery. So the purpose of the battery is to charge the capacitor. Means, try to understand here, it means charge is not sent like that. Why so? Suppose the battery which is connected across this plate, let's say the simple way, put it in a simple way, suppose the capacitor has to be charged by an amount of capital Q. This battery must having some potential difference across it. So it has some chemical energy within. Suppose the battery, and see all of you, the battery won't charge the capacitor at once. Suppose this capacitor needs, let's say, 100 microcoulomb amount of charge. It's not like that. This battery will send 100 microcoulomb of charge and it will place at once to this plate. It's not like that. It will send one by one amount of charges till it acquires 100 microcoulomb of charge, because its capacity to hold that amount of charge. It means, because of that reason, we can frame it like, to charge this plate of the capacitor, it needs, fully charged. To fully charge the capacitor, it needs some time. So at time t is equal to 0, we can say these two plates, they don't have any kind of amount of charge. The battery will sending in successive interval, the battery sends some amount of charge to the plate of the capacitors. Got? And see, suppose the battery is sending some amount of charge, and this charge, let's say this charge is minus here and this is plus. Let's say some out of 100 microcoulomb, let's say this is minus 1 microcoulomb and this is plus 1 microcoulomb. So because there is a charge separation and there exists one electric field here. You are getting my point? Because this plate is positively charged and this plate is negatively charged, in between the plates one electric field is set up. Clear? Now see, these two charges, what is sent by the battery at the beginning at time t is equal to 0, just it started sending the charges. There the battery has to perform 0 amount of work, as the potential difference across the two plates was 0. Gradually, when the battery is sending the charges, this acquires a positive potential and this plate acquires a negative potential. So there exists a potential difference. Now when the battery is sending further amount of charge, earlier there are some other positive charges here. So the battery has to perform some extra work to send further amount of charge, as here already a positive charge is there. Try to understand it. This plate is having a positive charge. Now it is connected to the positive terminal. Now what is being done? Since the battery is sending a positive charge, again this positive charge and that positive charge they may repel. It means what? Against that repulsion, that battery has to apply force or forcefully send the charge. Means it has to spend some energy to overcome that repulsive force and place the charge there. So it means it will lose the energy, and energy once lost, it must be stored in other form. So we can say in this process, the process will last long till 100 microcoulomb amount of charge is sent by the battery to this plate. So gradually, see, in the beginning it is 1 microcoulomb, in the next step it will be 2 microcoulomb, 3 microcoulomb, 50 microcoulomb, and finally it is 100 microcoulomb. So gradually, with the increase in the amount of charges, the repulsive forces gradually it increases. So the work done by this battery will gradually increases. So it is not a constant term. Clear? And finally, whatever be the amount, net total amount of charge in sending this total 100 microcoulomb amount of charge to the plate of the capacitor, that energy gets stored in the form of electrical potential energy. Why electrical potential energy? Because in this region, once the capacitor gets charged, in that region it sets one electric field. Clear? And that because of this, the field is electric, and that's why the energy stored within this region is called electrical potential energy of the capacitor. Clear? So now let us derive one formula for your electrical potential energy or energy stored in a capacitor. So as we know, the work done by the battery, it is not a constant. As the charge sent from the battery, sent by the battery increases, so the amount of work done gradually increases till it gets the saturated value or the maximum value of amount of Q. So for that reason, suppose let us understand this point, at t is equal to 0, the charge on the plate of the capacitor is 0 and the potential there also 0. The potential difference across the plate is 0. And to charge the capacitor fully, we need t time. So at that point of time, the charge on the capacitor is Q and the potential difference across the plate would be V. Got? So let us take an intermediate step, intermediate time between 0 to t, where the charge on the capacitor is Q and the potential difference across the plate is V dash. Got? And we know the formula for capacity, it is given by Q by V, or which is equal to Q by V dash. Yes, the charge and the corresponding potential difference. Suppose in some intermediate of time, the battery has already sent a charge Q to the plate of the capacitor. During that point of time, the potential difference is V dash. And at this potential, suppose the battery wants to send some further amount of charge dQ. So the total charge on the plate of the capacitor is Q plus dQ and the potential remains the same. Why? Because this is a very small amount of charge. It won't changes the potential of the plate appreciable amount, by an appreciable amount, as the value is very, very small. So at this potential difference, the battery has to perform some amount of work, and the amount of work is given by, then means W is equal to VQ. In that formula we can have, since the charge is very small and the potential during that point of time, potential difference at that point of time is V dash. So your work done dW is equal to V dash into dQ. And V dash, from here we can find V dash is how much? V dash from this C is equal to Q by V dash. So V dash is equal to Q by C. Now we can take this and put it here. Now here you all of you just see your dW is equal to Q by C into dQ. Means it's a very small amount of work in sending dQ amount of charge to additional dQ amount of charge to the capacitor by the battery. So while to send this capital Q amount of charge, the total work done will be how much? So W is equal to 0 to W dW's integration. Now you can put the value of dW here, which is Q by C dQ. As Q is a variable one, its the value changes from 0 to capital Q. So we can take the limit here, 0 to capital Q. Capacity, it is a constant term, so your 1 by C, it is taken outside the integration, and here the power of Q is 1, so we can apply the formula, that is Q to the power 1 plus 1 by 1 plus 1, it is a formula for integration, so which is Q square by 2, so and the limit is 0 to Q, and which implies finally W is equal to 1 by C, so instead of this Q square, it is Q square by 2 minus 0 square by 2. Now you are getting W is equal to Q square by 2C, which is equal to your U. U means your potential energy, and we can write here it is electrical potential energy, UE. So means the energy stored in a capacitor is given by the formula W is equal to Q square by 2C. Now here Q is the final charge. So when the charge on the capacitor is Q, at that point of time the potential difference across the plate will be V. So we can replace either of the term Q or C to get another formula. Like once you replace your this what I have done here, I kept one Q and written Q by C, that another Q divided by C. So half Q, and this Q by C is your potential difference there. This, if you take V there, Q by C will be your V. So means another formula for energy stored, which is half of Q into V. And finally if you replace Q by the formula CV, Q is equal to C into V, I am going to get it is Q square means CV square by half into C. So C here it is C square, it is C got cancelled, and you are going to get half CV square. So these three formulas, Q square by 2C, half into QV, half CV square is nothing but the energy stored in a capacitor in the form of your electrical potential energy. And as I have said you, in between this we are getting one electric field, and the value of the field is almost uniform. So means whatever work is being done or whatever energy is spent, that is stored within this region of the capacitor. Suppose you have a parallel plate capacitor whose plate separation is D and the plate area is A. Now the volume, suppose this is a parallel plate capacitor, so we can get the volume of the capacitor V, volume, let's say it is small v, is given by A into D. So we can define another term that is called your energy density. It's most important. Energy density means this amount of energy is spent by the battery and the energy is stored in the capacitor, but the energy is stored within that volume. Within this space the energy is stored. So what is the energy stored per unit volume? So energy stored per unit volume, U is given by, means energy stored per unit volume, means which is UE divided by V, it is called energy density, which is small u. Got? So if you take a parallel plate capacitor, then we can find this one. So UE, so you can write small u is equal to UE, so which is, we can take this formula, half C into V square divided by V. V is A into D, so which is equal to half. For a parallel plate capacitor, C is equal to epsilon naught A by D, and which is, now you see, so from this formula we can check it. V is equal to E into D, V is equal to E into D. Here E is the electric field between the plates of the capacitor, and this dr is the gap between the plates, which is D. So V square is equal to E into D whole square, so which is given by half, which is AA got cancelled, and which is epsilon naught by D square, and this term would be E square into D square. So D square got cancelled, and I am getting your energy density is half epsilon naught E square, where E is the electric field within the parallel plate capacitor. So this is the entire formula. This is most important formula. Thank you.